Okay, so welcome back. So now what we're going to do is, this video, we're going to talk about this one, and we want to show that this is indeed a geometric series. Okay, even though the index doesn't start at 1, and we've got something different here than n minus 1, but let's show that this is indeed a geometric series by first writing out several terms. Okay. So we can write this as, well, if n is 0, then we get 2/3 squared, right? Okay. And then plus, and then when n is 1, we get 2/3 cubed. Plus 2/3 to the 4th plus 2/3 to the 5th, and so on. Okay, now we would like this to start at 1, right? N minus 1. And we'd like this to be n equal to 1, right? We want to start at n equals 1, and then we would like this to be n minus 1. Okay. So let's simplify this even further. Okay. And we know that if we simplify this, we might see something else. So I'm going to write this. This is going to be 4/9, right? And what I'm going to do is I'm going to write this as, split this up as 2/3 squared times 2/3. And this is going to be 2/3 squared times 2/3 squared plus 2/3 squared times 2/3 cubed, and so on, right? And so if I write this again, this becomes 4/9 plus 4/9 times 2/3, right? Plus 4/9 times 2/3 squared plus 4/9 times 2/3 cubed, and so on. Okay. Now, what does this look like now? Well, I've got the first term is 4/9, right? And then I've got that common factor of 4/9, and then I've got this ratio, right? This ratio that starts at 0, right? And then 1, because I could put 2/3 to the 0 power here. And then all the way to, for infinity, right? So, but what I can do is I can rewrite this as what? I can rewrite this as 4/9 times what? 2/3 to the n minus 1, and n equals 1 to infinity. Now, so that will give me the same thing, right? Because if I put in n equals 1, I get 0, and I get 4/9. If I put in 2, I get 2 minus 1, which is 1, right? So I get 4/9 times 2/3. That's that term. And then for 3, I get 2/3 to the second power times that. So that one gives me, so yes, so this is the same as this, but this is the same as this, which is the same as this. So these two sequences are the same. And so it's a geometric series. Where A is 4/9 and R is 2/3. Now, since R is less than 1, right? The absolute value of R is less than 1, therefore this thing converges, right? And so what does it converge to? It's going to converge to, again, so n equals 1 to infinity of a r to the n minus 1. If the absolute value of r is less than 1, it converges to a over 1 minus r, right? Okay, so now, again, in this case here, A is 4/9. And R is 2/3. And so now we simplify this thing, right? We don't want to leave it in this form. So this is going to equal 4/9 divided by, well, 1 minus 2/3 is 1/3. Right? And so this equals what? 4/9 times 3. So the answer is 4/3. And so we just showed that this is indeed a geometric series, right? And we rewrote it in this form, and in this form we can see what A is, what R is, and then we can see that because the absolute value of R is less than 1, it converges, and it converges to this, which gives us 4/3, and we're done. See you next time.